Welcome back. This is the second lesson recording for IM2, September 24th, 2020. Where we left was with this question: do I really need all 6 pieces of information to decide 2 triangles are congruent? See, in math, we're always looking for simple, but not too simple that it loses things, but we're looking for simplifying things as much as possible. So in this case, you're given 2 triangles with 3 angle measures and then 3 sides. So we have 6 different information. Okay, in this case, do we need all 6? Well, at the very least, we know that if we took away one of the angles, like 42 degrees here and 42 degrees here, we can say that we know how to calculate the third angle when you know the 2 angles. Why? Because we can use triangle sum to calculate the missing angle. So we can conclude that that's too much information. At the very least, we only need 5. Okay? But is that it? Well, the other extreme is, what about if you only have one information? Well, that doesn't really make sense. For sure, you can make many different triangles. What about 2 sides? If you're given 3 and 7 as the side length, can you create more than one unique triangle? As you can see, yeah, you can create infinite number because this could be angled at any different ways. Okay, it turns out the minimal but sufficient number of information to conclude congruence is 3. So, but which 3? Is it 3 sides, 2 angles and a side, 2 sides and an angle, or which angles and which sides? Well, the combinations that are possible is side, 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 angle, 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 side, angle, side, angle, side, side, angle, 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 side, and angle, side, side, or side, angle, angle. Okay, those are the all combinations of sides and angles that we could have. But look at this, side, side, angle, and angle, side, side. It's really the same thing because you're just looking at angle, side, side. Depending on which direction you're looking at, they are the same thing. So we can actually just cross out one of them and say, hey, if we know that side, side, angle works, then we know the angle, side, side works. So we only just need to explore this one. And likewise, angle, angle, side, and side, angle, angle, they are just the same thing. So we only need to worry about one of them. Okay, so right now we just need to explore all these 6 different combinations of information. To do that, you're going to go to GeoGebra link. That's right there. I did put it on the chat or during the class, and you can click on it if you are watching this from home. Okay. So please go to the GeoGebra link that you see here, and you are going to read the information here and follow it and then see if you can come to the right conclusion. Okay, it says set the segment to the desired length. So these are the length, and you can vary it any way you want. Okay, however, if I make this too long, am I going to be able to make a triangle? I can certainly move these parts, but will the third point ever meet? No. Remember our triangle inequality? It said that the third length has, if you are given 2 length, then the third length has to be less than the sum of. So 6 plus 7 is 13. So this has to be less than 17. So I'm going to, let's make it that, I don't know, 12. Okay? Alright, then AC and BC, you can adjust it. I'm just going to leave it as it is. And can I form a unique triangle? Yes, because that's where I need to go. That's the meeting point for both length. That's it. So that's my unique triangle, and I could only form just one triangle. There are no multiple triangles I could form given this side length. So this tells me that if you have 3 different sides, the side, side, side does create a unique triangle, which means that it is a valid congruence rule. Let's try SAS, side, angle, side. In this case, you are given side AC and a angle in between, and followed by another side. Okay, so you're given side, angle, and side. You need, when you are figuring out which rule to use, you need to go in one direction. You cannot skip. Okay, so you need to find the information you have, side, and then just keep going. Do I hit any angles? Yeah, I hit an angle, so that's angle, and then followed by a side. Okay, so you can again adjust to any length you want. Okay, but and you can change the angulation too. Okay, but given any length that you've made, can you create multiple triangles? Okay, so if I have 6 as the AC, and if I have AB as being 10 with 40 degrees, the only possible triangle is this. Okay, so I need to move this. I need to move it. Okay, so I need to shorten it in order to make this triangle. Okay, so now that's the triangle formed. Okay, so it has a set length it needs to be. So the angle, the side, angle, side does create a unique triangle. That means side, angle, side is a valid congruence rule. Alright, let's try angle, side, angle. What if you are given 2 angles with the side in between? So again, you can move this, you can change the angulation to what you want, but just explore. Okay, if you give an angle and a side and an angle, really the only triangle that you could possibly form is if you extend this to meet right there, right? So this length is fixed, and this length is also fixed if you have angle and the side in between the 2 angles and another angle. So this is angle, side, angle, not angle, angle, side, because we have to, when we're counting, we have to go in the same order. We have to go into one direction. So we have to go, start from here, there is an angle here, and then start moving. Okay, and there is the side that we come across, and then finally the angle. So angle, side, angle does create a unique triangle, which means it is a valid congruence triangle rule. Let's do angle, angle, side. Alright, so angle, angle, side. This time the side is not included. Before it was angle, side, angle, we were given this side that was in between the 2 angles, but this time we have 2 angles followed by a side. Again, you can change the length and the angles, but if I am given this length 15 and I need to make 57 degrees here and I need to make 69, the only way I can create this triangle is by moving it until that point passes through the vertex B. Okay, that creates the triangle. Okay, and again, this just creates a unique triangle, meaning this length is set, all the other unknown lengths are set, and all the other angles are also set. So therefore, angle, angle, side is a valid congruence rule or state condition. What about side, side, angle? Okay, if you're given this side and the side and then another angle like so, so remember we have to go from one direction. Okay, so we have to start from, okay, we have a side here. Do we have a fixed angle here? No, we don't. So that just becomes side and then side. Do we have an angle here? Yes, we do. So it's side, side, angle. So then we need to be thinking, okay, can I create, how many triangles can I create? So I can move this to meet right there. That's a triangle. So my triangle looks like this. However, there is another triangle that I can form with that same dimensions. There is another one. Okay, so there are two different triangles that can be formed with exactly the same dimension that we're given. That means that you can't say that the two triangles are congruent, because you could have created two different triangles with the same measures. So side-side angle is not a congruence rule or condition. Okay, let's explore the very last one. That's HL. What does HL stand for? It's the hypotenuse and the leg. Hypotenuse, leg. And this is only applies if in the right triangle. This only applies in the right triangle. And hypotenuse only occurs in the right triangle. So hypotenuse is always the side opposite the right angle. So in this case, we're told that because of this line, we know that the angle A is the right angle. We know that this is angle A is right angle. And we're given the leg to be 4 and hypotenuse is 5. So leg is 4, hypotenuse is 5. That means I need to move this until I form a triangle, and that is the only triangle I could possibly form. Okay, I could form another one right here, but that's exactly the same triangle, isn't it? Because they are just a reflection from one another. So this does turn out to be a valid congruence rule. Okay, but haven't noticed this. This actually is just a special case of angle, side, side. Remember we said that angle, side, side, or side, side angle is not a valid congruence triangle rule. Okay, but this happens to be a special angle, side, side. And this is only true if you have a right angle and you have hypotenuse length and one of the legs. Okay, so let's summarize what we've discovered. Okay, so we know that side, side, side works. Okay, we know that side angle side works. We know that angle side angle works. Okay, now when we've discovered that angle angle side also works, but we did discover that side side angle does not work. And remember, this is the same thing as this. Okay, and so we're actually not going to consider this because angle angle side. So we have 4 things that are valid congruence conditions, but plus we do have HL, which is a special case of angle side side when it involves a right angle. Okay, what about angle angle angle? Well, let me draw a quick, let's say this is 20 degrees, this is 30 degrees. Okay, what's this going to be? This is going to be 150, so this has to be 130 degrees. Okay, if I was to draw another triangle with exactly the same measures, so this is 30, 20 degrees, and this is 130 degrees. Okay, even though the corresponding angles are exactly the same in measure, okay, obviously these two triangles are not congruent because they are similar, but they are sort of bigger version of one another. So we know that angle 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 is not a valid congruence statement. Okay. Okay, so you're going to take some notes. So I am going to go through this quickly. So please pause the video and write this down. Side angle side, angle side angle, angle angle side, and hypotenuse and leg.